So good day everyone. We're here to discuss about frequency distribution. And here are the reporters, Clan Jansano, Rafael Ralota, and Jomer Abilia. Frequency distribution, it is a tabulation or grouping of data into appropriate categories, showing the numbers of observation in each group or category. Consider the given data below, which show the scores of 60 students in a statistic test. So, the numbers shown above are called raw data. So, here are the parts of frequency table. Number 1, class limits. Grouping or categories defined by lower and upper limits. So, here are the example. 16 is the lower limits and the 20 is the upper limits, and 21 is the lower limits and the 25 is upper limits, and 26 is the lower limit and 30 is the upper limits. So lower class limits are the smallest numbers that belong to the different classes, and while the upper class limits are the highest numbers that belong to the different classes. So number 2 are the class size, a width of each class interval. So for example here, the lower limit is 16 and the upper limit is 20. So the class size of the interval is 5, and so on as 21 and 25. Number 3. So class boundaries. Class boundaries are the numbers used to separate class but without gaps created by class limits. The number to be added or subtracted is half and different between the upper limits of one class and the lower limits of the preceding class. For example, so here are the example on how to get the class boundaries. So we're going to subtract the first upper limits and the second lower limits. So for example, 21 is the second lower limits and the first upper limit is this 20. So we're going to subtract those and we get the answer 0.50, and you're going to that 0.50 you are going to subtract it to the lower limits, which is the 16, 21, 26, and 31. So when you subtract it, you're gonna get 15.5, 20.5, 25.5, 30.5, and so on. You're gonna get that 0.50 and add it to the upper limits. So you're going to get the 20.5, 25.5, 30.5, and 35.5. So that's how you get the class boundaries. So number 4, the class marks are the midpoint of the classes. They can be found by adding the lower and upper limits and divide it by 2. So for example, this is how you get the class marks. 16 plus 20 equals 36 divided by it by 2. Let's hear from Rafael, and he will going to discuss about the next step of frequency distributions.
Set up the class limits of each class. The limits of each class are defined by a lower limit and an upper limit. To determine the constructing classes with the class width, the highest observation should be the part of the highest class interval. Example, we have a class width with 4. So let's put it 76 as the lowest. So 76, 77, 78, and 79. That is how we make our class limit. 4th, set up the class boundaries. The class boundaries are true limits of a class is defined by a lower class boundary and an upper class boundary. This is obtained by getting the midpoint of the lower class limits of adjacent classes. Based on the example earlier, 76 and 79. So our class boundaries is 75.5 and 79.5. Fifth, tally the scores in the appropriate classes and then add the tallies for each class in order to obtain the frequency.
Cumulative frequency distribution. The less than cumulative frequency distribution is obtained by adding successively from the lowest to the highest interval, while more than cumulative frequency distribution is obtained by adding frequencies from the highest class interval to the lower class interval. Relative frequency distribution. The relative frequency of a class is the frequency divided by the total frequency of all classes and is generally expressed as a percentage. Graphical representation of the frequency distribution. The following graphs can be constructed to represent a frequency distribution. A histogram consists of a set of rectangles having bases on a horizontal axis with centers at the class marks and lengths equal to the class interval sizes. Frequency polygons are constructed by plotting class frequencies against class marks and connecting to the consecutive points by a straight line. Ogives is obtained by plotting the cumulative frequency by connecting points of intersection between the class boundaries versus cumulative frequencies less than or more than. That's all. Thank you.